Okay, let's go to page 334 to check the phasor or voltage phasors of RC capacitor. Okay, so questions one. In the RC circuit, the voltage across the resistor, so VR is that much, and the voltage across VC is that much. So I probably write down one more time. VR is 2.7 and VC is 4.2. They want to use sketch and label VR and the VC. So what do you need to use? What concept do you apply for this one? Okay, remember ICE and I is VR. Am I right? I and VR, they are in phase. So this is VL. So we know VR lead VL. Okay, so VR, if this is VR, VR 2.7, so probably make it shorter. So this is VR. And lead the VC, so VC is longer. So VC is longer. Okay, so VC is here. Okay, roughly. Okay, you can see that VR is shorter and VC is longer. So this is question one. Use ICE. Okay. Question two, on the diagram and label the phasor that represents the supply voltage or total voltage. So we are going to do supply voltage and total voltage. And you know supply voltage and total voltage is VR plus VS. Am I right? Because they are in series. Okay, so we add them together and by phasor, by vector. Okay, so where is our VS? So we add this together. So this is our VS. Okay, and then we want you calculate the supply voltage is how much. Okay, so what can we use? Okay, I think you know already is Pythagoras. So Vs equals to VR square plus Vc square and square root. So we put a number in. VR is 2.7 square and Vc is 4.2 square and take the square root. And from calculator, what would be the answer? Okay, so it's 4.99 volt. Okay, you can round it to 5 volt. Okay, because we got two decimals. So if you round it into two signal figures, it will be 5. Okay, so this is our answer for VS. Now they want you find the phase difference between what and what? Between VR and the VS. So VR is here, VR is here, VS is here. Okay, so what is the angle? So the angle theta is here. Okay, and VR and the VS. So we can use VR VC. We know VR VC. Am I right? We know VR and VC, so we can use arctangent. Okay, so theta. So theta equals to how much? Arctangent. What? Opposite. What is opposite? This is opposite. Okay, this is opposite. Opposite is how big? How probably blue. Okay, blue is better. So this is VC. Am I right? They are VC. Okay, so this is arctangent. So this is VC, and adjacent is VR. Okay, and now we can put the number in. So which is arctangent, and VC is 4.2. and VR is 2.7. Okay, so the answer by calculator is 57.26 degree, and we can round it to 57 degrees. Okay, so I think that is the answer for this one. Now write a statement that describe the phase difference between the quantity on the graph. Okay, so how do we do this one? I think in our mind we need to know I and VR, they are in phase. Okay, other than that I think we can do that. Okay, so we write VC and the VR. Okay, VC and the VR. So we check VC is here and VR is there. So VC is here, VR is here. Okay, so VC is here VR is here. And what does that mean? Okay, so VC is legs. VR by how much? By 90 degree. Am I right? Okay. And now VR and the VS. So how do we do VR and the VS? Okay. Remember our diagram. VR is here, and VR is here, and VS is here. Am I right? If you check the diagram, VS is there. Yeah. Okay. And here is 57 degree. So how do we do VR VS? So VR leaders. VS by how much? By 57 degree. Okay, and now VC and the VS. VC and the VS. So VC is where is here. Okay, VC and is behind. Am I right? So it's legs. And by how many degree? 90 minus 57 is 33 degrees. Okay, so I use the older VR and the VC. Okay, and if you swap these two, okay, you can say VR lead the VC by 90 degree. And so if you swap the older VR and the VC, or VS and the VR and the VS, you need to change the legs to leaders. Either one is fine. Okay, yeah. Okay, so now in terms of phasor, describe the relationship between the current. Okay, current, as I said, the current and the VR are in phase. Okay, so current and the VR, so we have to current and the supply. So the question is asking you, so current, and it is actually in phase with VR, and this is VS. Okay, so they are asking you VR and the VS. Okay, so you can write VR is current, so you can write the current leaders. Okay, leaders VS, okay, by 57 degrees. Okay, or you can swap an order and change you can say VS leg current by 57 degrees. Okay, but they want you discuss. Okay, they want you discuss. So we state the relationship now. Okay, and we want to do some discussion. So how can you discuss, and how can this happen? Okay, why is not 90 degree or not in phase? Okay, and you can say this is our VR and this is our VC. Okay, and you can write it because capacitor VC legs by VR 90 degree. Okay, and because this one slow down the VS. Okay, slow down the current. Okay, so the current is there, and because we got capacitor. Okay, so capacitor slow down, or probably check the side page to see how they write, but basically voltage slow down. Okay, slow down because legs, so they slow down the current. Okay, make it slower than it should be. Okay, hope this makes sense.